Welcome to the third part of Maths chapter, Continuity and Differentiability. So we are on our seventh question. It says that find the value of a for which the function f defined as f of x is equal to a sine pi by 2 bracket x plus 1, where x is smaller than or equal to 0, and f of x is equal to tan x minus sine x upon x cube, where x is greater than 0. This function is continuous at x equals 0. So if this function is continuous at x is equal to 0, we have to find the value of a. So if we approach the value of this function from left hand side and right hand side and at 0, right, we will find same value throughout, because they are saying that this function is continuous at x is equal to 0. So let us start with your left hand limit. Okay, so LHL, that is your left hand limit, equals to limit of f of x when x tends to 0 minus, that is we are approaching 0 from the left hand side. Left hand side, that means we are on a number which is smaller than 0, and whenever we are on the left side of 0 at a number which is smaller than 0, the definition of the function is a sine pi by 2 bracket x plus 1. Okay, so remember that. Okay, now moving ahead, this becomes limit of x a sine pi by 2 bracket x plus 1 when x tends to 0 from the left side, 0 minus. Okay, now we will replace this 0 minus with h. Okay, the h method. So limit when h tends to 0 of a sine pi by 2 bracket, in the place of x I'm going to write 0 minus h plus 1. In the place of x I'm going to write 0 minus h plus 1. Now we know that h itself is tending to 0. H is moving towards 0. That means h is becoming so small that it is very close to 0. So what we can do is we can remove limit and directly convert h to 0 only. So this will become a sine pi by 2 bracket 0 minus 0 is 0, 0 plus 1 is 1. Anything into 1 remains the same. So a sine pi by 2 will be a into 1. Sine pi by 2 is 1. So the LHL gets equal to a. Now let's talk about RHL. Okay, RHL is limit of f of x when x tends to or x approaches 0 from the right hand side, that is 0 plus. So this will give us limit. Now what is the value of the function for all the values which are greater than 0? Tan x minus sin x upon x cube. Tan x minus sin x upon x cube. Okay, now limit when x tends to 0 plus, that was our criteria, our RHL, but we know that in the next step we have to let go of the 0 plus and express the limit in terms of h. When h tends to 0, this will become wherever there is x we will write 0 plus h. So tan of 0 plus h minus sine of 0 plus h the whole upon 0 plus h the whole cube. 0 plus h the whole cube. Okay, now just now you should not convert everything like in terms of h, like you don't convert h into 0 right now in this step, otherwise the whole function will become meaningless. what you should do is write one more step in terms of h, limit h tends to 0 of tan h minus sine h the whole upon h cube. So what you're doing is you're writing the whole function in terms of h. Now, because we have studied how to you can say evaluate trigonometric functions. We have studied this in class 11th, how to evaluate trigonometric functions. So you should be able to simplify this thing which is here right now. Okay, let's try to simplify this. Tan h minus sin h upon h cube. Okay, let's first write. I will write over here. Okay, let me make a division here. Okay, limit h tends to 0 of tan h. Tan h is sin h upon cos h. Sin h upon cos h minus sin h the whole upon h cube. Okay, so what will we have here? Let's see. Limit h tends to 0 of sin h minus sin h cos h the whole upon h cube into cos h. Okay, so this will become limit h tends to 0 of, let's take out sin h common, we'll get 1 minus cos h the whole upon h cube into cos h. Okay, this looks okay. Now what? Now if you remember the formulae of trigonometric limits from last year, you would remember something like this: sin h upon h. What is limit of sin h upon h when h tends to 0? You remember that? That is 1. That is 1. Okay, if you don't remember, it's not a problem. It is kind of a revision for you, but you must remember. Okay, so next thing is, okay, we have written sin h upon h, so we are left with the remaining part of the function. Let's write that also. 1 minus, okay, let me not put limit over again, otherwise you get confused. Let me write it as 1 minus cos h upon h square. Now where did this h square come from? See, we had h cube in the denominator. One of the h I have written over here and one over here. So what is now remaining? What is remaining is 1 upon cos h from the denominator. Now we are going to separate these terms. So we are going to separate all the limits. How? Limit h tends to 0 of sin h upon h into, or multiplied by, limit 1 minus cos h upon h square, limit h tends to 0, multiplied by limit h tends to 0 of 1 upon cos h. Okay, so here we have three different terms involving limits. Let us simplify them further. So limit of sin h by h when h tends to 0 becomes 1. Okay, so that is, if you remember, that is the formula, the standard trigonometric limit formula. Okay, so this one becomes 1 multiplied by let me write limit 1 multiplied by limit h tends to 0 of this 1 minus cos h. I'm going to write it as 2 sine square h, 2 sine square h by 2, 2 sine square h by 2 upon h square, 2 sine square h by 2 upon h square. Okay, so why I'm writing 2 sine square h by 2 over here? That is the formula of 1 minus cos theta. Why I'm bringing in terms of sine theta? Because I want to find the value of the limit of this trigonometric function. So in cos, in the terms of 1 minus cos h, it will be very difficult to take the answer of that. Acha, what about limit of 1 minus cos h when h tends to 0? This will simply become 1 upon cos 0. Okay, because this cannot be simplified further. It is already in terms of cos. Okay, so 1 into this into 1 upon cos 0, and cos 0 is also 1. Cos 0 is also 1. So that this whole fraction becomes 1. There is 1 already. Now we just have to simplify this. So limit h tends to 0 of let's say, okay, let me write it as 1 by 2 . Okay, there is one interesting step over here. Since we want sine h by 2 upon h by 2, and we have sine square h by 2 upon h square. So to bring sine h by 2 upon h by 2, of course there will be a square, so we can make it whole square. What we'll do is divide the numerator and denominator by 4. So by dividing the numerator and denominator by 4, you will see what happens. So 2 sine square h by 2 the whole upon 4, the whole upon h square upon 4 multiplied by 1. So limit h tends to 0 of, now see, this will become half multiplied by sine square h by 2 the whole upon h square by 4. Okay, now look at this very carefully. I can take out this half out of the limit, like, because it's a constant, so no limit applies to it. Half into limit of h tends to 0 multiplied by sine of h by 2 upon h by 2 the whole square. Okay, now this is nothing but 1. Sine x upon x, limit when x tends to 0 of sine x upon x is 1. So this whole thing becomes 1, and we get our RHL, the right hand limit, as RHL is going on. So our right hand limit, therefore right hand limit is equal to half. Now we know that this function is continuous at 0. So since f of x is continuous at 0, therefore we can say that LHL is equal to RHL at 0. LHL is equal to RHL at 0. Now just see what is our LHL. Our LHL is A, and what is our RHL? RHL is 1 by 2, and therefore we can say that A is equal to 1 by 2. So for the value of A equal to 1 by 2, this limit, this function is continuous at 0. So this is how you solve this question based on trigonometry. Let's go to the next question. Okay, find the value of a and b such that the function defined by f of x is equal to 5 when x is smaller than equal to 2, f of x is equal to ax plus b if x is between 2 and 10, and f of x is equal to 21 if x is greater than or equal to 10, is continuous. Now this function is everywhere continuous. So for the point of discontinuities, or for the point at which the function could be discontinuous, we have 2 and 10. We have to verify the continuity at 2 and at 10. If we could verify the continuity at 2 and 10, we get two equations of a and b, and we solve those two equations, and we find the values of a and b. Let's do it. Okay, let's start. Okay, first we will verify the continuity at 2. Okay, so limit when x tends to 2 minus of f of x, we are approaching 2 from the left hand side. So of course when we approach 2 from the left hand side, the value of this function is constant, which is 5. Okay, left hand side means we are at a number which is smaller than equal to 2. Okay, so value of the function is 5. Okay, when we approach limit of this function when x tends to 2 plus from a number which is greater than 2. Now when a number is greater than 2, the function assumes the value ax plus b. Now what we'll do is we will try to simplify this function further by using the h method, right? So limit h tends to 0 of this function becomes a bracket, okay, x is tending, x in the place of x I'm going to write 2 plus h, 2 plus h plus, sorry, 2 plus h bracket close plus b. Now as h is tending to 0, so this is 2a plus b, right? So this is you can say the RHL, the value of RHL of this function at 2, and the value of LHL is 5 at 2. Okay, so we've got the value of LHL and RHL, but LHL is equal to RHL. Why? Because this function is continuous. It is continuous. They've already said that, and therefore we can say that 2a plus b is equal to 5. This is our equation number 1. Okay, now let's check the continuity at the second point. The second point is 10, of course. So limit of x tends to 10 minus, we are approaching 10 from the left hand side, from the numbers which are smaller than 10, of f of x. It will give you ax plus b, because any number between 2 and 10 will give the value of this function as ax plus b. Now let's use the h method. So limit when h tends to 0 becomes a bracket 10 minus h plus 10, 10 minus h plus, hey, plus b, it's not 10, sorry, plus b. Okay, now h is tending to 0, so h will become 0, and this, the value of this limit or value of this function when h tends to 0 will become 10a plus b, 10a plus b. Now we know that this is the LHL. Now we'll find RHL. So limit x tends to 10 plus of f of x. So we are tending to this function from the right hand side of 10, and on the right hand side of 10 the value of x is of course greater than 10, and the value of this function when x is greater than 10 is 21. So we'll directly write 21 over here. So therefore we can say that the limit x tends to 10 plus is equal to 21. That is the final answer, and therefore we can say LHL is equal to RHL all over again. Why is LHL equal to RHL? Because the function is continuous. So LHL is 10a plus b, RHL is 21. So 10a plus b is equal to 21, and this is number 2. Okay, so we have got two linear equations in two variables. 2a plus b is equal to 5 and 10a plus b is equal to 21. Now, if you solve these two linear equations in two variables, you will get the values of a and b. That's very simple. Okay, so I hope that you will be able to solve. Try to solve and pause the video and solve the answer, solve this equations and get the answer and verify the answer with me. Okay, you're done. Let's check the answer. So the answer is A is equal to 2 and B is equal to 1. Okay, if that is your answer, you are correct. You now understood the method of solving questions based on functions. Limits. Okay, what is this question? Find the relationship between A and B so that the function defined by f of x is equal to ax plus 1 if x is smaller than equal to 3 and bx plus 3 if x is greater than 3, if this function is continuous at 3. So it's very easy. Limit when x tends to 3 minus, we are approaching 3 from the left hand side, that is from the numbers which are smaller than 3. If we approach x from the numbers which are smaller than 3, the value of this function becomes ax plus 1. So of f of x is equal to ax plus 1. But we want to find the exact value, not in terms of x. So we'll use limit h tends to 0 of f of x. Now this will become a. In the place of x, we are going to write 3 minus h plus 1. Now h is tending to 0, so 3 minus 0 is 3, so 3a plus 1. Now this is the value of LHL. Okay, let's find the value of RHL. RHL is limit of f of x when x tends to 3 plus is equal to bx plus 3. Now limit h tends to 0 of f of x in this case will become b bracket 3 plus h plus 3. That is, h will become 0 and this will become 3b plus 3. Okay, so 3b plus 3. Now 3b plus 3, not 3b equal. Sorry. Now we know that RHL and LHL are equal. Why? Because the function is continuous at x is equal to 3. So we just simply equate LHL and RHL. So 3a plus 1 is equal to 3b plus 3. So that is 3a minus 3b is equal to 3 minus 1. So 3a minus 3b is equal to 2. So 3 bracket a minus b is equal to 2. So a minus b is equal to 2 by 3. A minus b is equal to 2 by 3. That's the relationship between a and b if the function is continuous at x is equal to 3. Let's see. Let's check the answer. Okay, the relationship they have written like this, but the answer is absolutely correct. Let's go ahead. One more trigonometric question. Very good. And this is from 2009. Please beware of this year 2009. The questions 2009 and 2014, the questions were little tricky of those two board papers. Okay, show that the function f of x defined by sin x by x plus cos x when x is greater than 0 and 4 bracket 1 minus root of 1 minus x upon x, the whole upon x, when x is greater than 0 is continuous at 0. So to show that this function is continuous at 0, we have to prove that LHL is equal to RHL. Okay, let's prove it. So let's first find LHL is equal to limit when x tends to 0 minus of f of x, which is limit of x tends to 0 minus of sine x. Hey, x is smaller than 0, right? So we have to take another formula. When x is smaller than 0, that is 4 bracket 1 minus root of 1 minus x bracket close the whole upon x comma x smaller than 0. Hey, we don't have to write that. Okay, now what? Now we will replace 0 minus with h to simplify it further. So limit h tends to 0. Limit h tends to 0 of 4 bracket 1 minus under root of wherever there is x, I'm going to write 0 minus h minus bracket 0 minus h bracket close the whole upon x. In the place of x, I'm going to write 0 minus h. Okay, let's see what it becomes. Limit h tends to 0. Okay, now uh, this is definitely becoming 0. So 0 minus 0 is 0, 1 minus 0 is 1, root of 1 is 1, 1 minus 1 is 0, and 4. Oh, we cannot solve this because the numerator is becoming, so this is coming into the form 0 by 0, that is indeterminate form. So we cannot solve this like this, so we have to do something different. Let's see what we do. So I was in little bit of hurry for applying the h method, but all questions are not alike, they are not simple. So let me do something different. Let me help you recollect the techniques which we used in the chapter limits in class 11th. So for some of the functions, what we did was 1 minus root of 1 minus x. We did rationalization, 1 plus root of 1 minus x the whole upon x bracket 1 plus root of 1 minus x. So I divided and multiplied by 1 plus under root of 1 minus x to simplifying this particular function further. So limit x tends to 0 minus of, now this will become 1 square minus under root of 1 minus x the whole square. That is 1 minus 1 minus x. So 4 bracket 1 minus 1 minus x the whole upon x bracket 1 plus under root of 1 minus x. Okay, let's simplify this further. Limit when x tends to 0 of 4. Okay, here this will be 1 minus 1 plus x. 1 minus 1 will be 0, 0 plus x will be x, so it will be just 4x upon, if I open the bracket, uh, this will be x plus x under root 1 minus x. Hey, there is no need to open the bracket. There is no need to open the bracket. You know why? Because this x and this x is getting cut right away. So what we are getting? Limit x tends to 0 of 4 upon 1 plus under root of 1 minus x. 1 plus under root of 1 minus x. Okay, now let's see if we can use the h method. Now I think we can use the h method. Okay, so limit when x tends to 0 when h tends to 0, and this is x tends to 0 minus, I'm sorry, I did not write it over here. So when h tends to 0, this would become 4 upon 1 plus under root of 1 minus, this will be 0 minus h. Okay, and 0 minus h is tending to 0, so this will be 0, 1 minus 0 will be 1, and under root of 1 will be 1, so 1 plus 1 will be 2. So limit of h tends to 0 will be, hey, now there is no limit, we can directly find the answer. We can directly write the answer as 4 by 2 or 2, directly 2. Okay, so answer comes out to be 2 in this LHL case. Now what about the RHL case? Let's write the RHL case. RHL is limit of f of x when x tends to 0 from the positive side, which is equal to limit of, now whenever we are approaching x from the right hand side, we have to use the first definition of the function, sin x upon x plus cos x. So sin x upon x plus cos x when x tends to 0 plus. Now do we need to simplify this, or how do we do it? Because if it is sin x upon x, we can separate the limits and we can simplify. Hey, let's try this. Limit of x tending to 0 plus of sin x upon x plus limit of x tending to limit of cos x when x tending to 0 plus, and let's try to solve this. So we will use the h method because with this form it will be little difficult to solve. Let's use the h method and then simplify it. So limit when h tends to 0, this will become 0 plus h. So sin h upon h plus limit of cos h when h tends to 0. Now limit of h tends to 0 of sin h by h is 1 plus limit of cos h when h tends to 0 is cos 0, which is also 1. So 1 plus 1, 2. So here also I am getting 2 as answer. Therefore LHL is equal to RHL, and this function is continuous at our number 0. So we also have to find the value of the function at 0. Now if you see very closely, they have said that the value of the function at 0 is 2. Okay, now what is LHL's value? 2. I will show you. See, LHL is 2, RHL is also 2, and the value of the function at the point 0 is also 2. That means this function is continuous at 0. We have proved that. I hope it is very, very clear by now. Okay. Okay, one more CBSE question. Find the value of k for which this function is continuous at 0. Now, I would want all of you to try this question. It is very simple question. Only remember that when you are approaching 0 from the left hand side, uh, that is when you are using the first definition of the function, that is this one. Remember to rationalize and simplify it. Okay, don't make the mistake of using h method directly because it is a little complex form. and the RHL side is quite simple, straightforward, so you can solve it. Okay, so why don't you pause the video and solve this question once for yourself, and then we'll check the answer. Okay, so I hope you have done this, and let's check the value of k, the final answer. Okay, so k is -1, for which this function is continuous at x is equal to 0. Check the method once. First, they have rationalized the numerator and denominator, simplified it, uh, then directly used, they did not use H method, they directly simplified and found the answer in terms of k. Okay, then in the RHL, they use the H method directly in the second step, simplified, and for continuity, they equated the limits of LHL and RHL, and they found it to be equal to k to be equal to -1. Okay, let's do the next question. This is 2016 CBSE All India. If f of x is equal to sine of a plus 1x plus 2 sine x, the whole upon x, when x is smaller than 0. If f of x is 2 when x is equal to 0, and f of x is root of 1 plus bx minus 1 upon x when x is greater than 0. It is continuous at 0, this function, and then find the value of a and b. So this is a trigonometric function, you need to be little careful. It is given that it is continuous, so let's start with LHL. Okay, LHL is limit x tends to 0 minus of f of x, which is limit of sine of a plus 1 x plus 2 sine x, the whole upon x when x tends to 0 minus. Okay, so this is equal to limit h tends to 0. Now I'm just replacing our limit from x tends to 0 minus to h tends to 0. So wherever there is x, I have to put 0 minus h. Sine of a plus 1 bracket 0 minus h plus 2 sine of 0 minus h, the whole upon 0 minus h. Okay, so this will be limit h tends to 0 of, now this will be sine of a plus 1 multiplied by minus h. So sine of minus theta is minus sine theta, so I can write it as minus sine of h bracket a plus 1 or a plus 1 bracket h, does not matter. Okay, here also sine of 2 sine of minus h, which is minus 2 sine h, minus 2 sine h, the whole upon minus h. Okay, now what I can do is, because there is minus sign common in numerator and denominator, I can take it out common and simplify. So limit h tends to 0 of sine of h bracket a plus 1 plus 2 sine h, the whole upon h. Now it is time for simplification, and for simplification I'm going to do something little you can say unusual. Just have a look. Limit h tends to 0 of sine of h bracket a plus 1 upon h bracket a plus 1. Now you must be thinking there is no h bracket a plus 1 in the denominator. Where did I bring it from? So I'm going to, just for the sake of convenience, I'm going to multiply with a plus 1 here in the numerator. So a plus 1 gets cancelled and it becomes as it is. Okay, plus 2 sine h by h. Now what will happen over here? We are going to simplify the limits. First, I'm going to split the limit h tends to 0 of sine of h bracket a plus 1 the whole upon a plus 1 multiplied by a plus 1 plus limit of 2 sine h the whole upon h when h tends to 0. Let's see what becomes of this. Okay, now here this a plus 1 will come out of the limit. We cannot apply a limit to a plus 1, so we'll write a plus 1 separately, and the limit when h tends to 0 of sin h bracket a plus 1 upon a plus 1 into h. I'm sorry, I did not write h over here. This becomes 1. So a plus 1 into 1 plus, here 2 will come out common. This 2 will come out common, and limit of sin h by h will become 1 when h tends to 0. So the value of LHL here will become a plus 1 plus 2, which is a plus 3. A plus 1 plus 2, which is a plus 3. Okay, now we'll find the value of RHL. Okay, so RHL is equal to limit x tends to 0 plus limit x tends to 0 plus of f of x. Now whenever we are approaching 0 from the right hand side, remember, whenever we are approaching 0 from the right hand side, we have to take the value of x greater than 0, and the definition of the function becomes root of 1 plus bx minus 1 the whole upon x. So limit x tends to 0 plus of root of 1 plus bx minus 1 the whole upon x. Okay, now before using any h method or anything like that, I would like to simplify this, the definition of this function, keeping the limit x tending to 0 plus under root of 1 plus bx minus 1 multiplied by under root of 1 plus bx plus 1 the whole upon x multiplied by under root of 1 plus bx minus 1. Hey, plus 1, I'm sorry. Okay, so this becomes limit when x tends to 0 plus of 1 plus bx, because under root of 1 plus bx the whole square becomes 1 plus bx minus 1 square, which is minus 1 whole upon x bracket under root of 1 plus bx plus 1. Now this minus 1 plus 1 gets cut, bx upon x gets cut, and we get limit when x tends to 0 plus as of b upon under root of 1 plus bx plus 1. Okay, so we have got so far. This is, I think, by far the most simplest step in after which you have to take out the limit. So let's use the H method and simplify this further and get the value of RHL. So limit when H tends to 0 becomes B upon under root of, in the place of X I'm going to write 0 plus H, so 1 plus B bracket 0 plus H plus 1. So limit when H tends to 0 B upon, just a moment, okay, so this will become 1 plus BH, and hey, H is tending to 0, right? So this will become wait, let me simplify this. Okay, so H is tending to 0, B into 0 will become 0, 1 plus 0 will be 1, root of 1 will be 1, and 1 plus 1 will be 2. So this will be nothing but B by 2, correct? So we know that RHL, the value of RHL becomes B by 2. Now LHL is equal to RHL, is equal to the limit of the function at 0. Okay, so LHL is A plus 3, RHL is B by 2, and limit of this function at x is equal to 0 is 2. So A plus 3 is equal to 2, so A is equal to minus 1 and B is equal to 4. A is equal to minus 1 and B is equal to 4. So these are the values of A and B, and we have completed this question successfully. Okay, the final question of this continuity chapter or topic, you can say. Show that the function f defined by f of x is equal to mod of 1 minus x plus mod of x when x belongs to real number is continuous. Okay. Understand few concepts before going to this question. Now in this function f of x, there are two separate functions which are existing within, that is mod of 1 minus x plus mod of x. So one of the function which is existing inside it is mod of x, and as a whole, if you see, this thing as a whole is a function. Okay, so if you say we have to show that this function is continuous, we have to identify which functions are involved in this given function. So one function which is involved is g of x, which I would write it as 1 minus x plus mod of x. The other function which is involved is h of x, which is nothing but mod of x, where x belongs to the set of real numbers. Okay, now if I ask you that what is HOG of x, HOG of x, what do you get when you find HOG of x? HOG of x can also be written as H of g of x. H of g of x means you put this whole thing into the other function, that is mod of x. Okay, if you put g of x inside in the place of x, you get h of g of x. Okay, can I write h of g of x as h of 1 minus x plus mod of x? Yes, I can. And what is h of 1 minus x plus mod of x? It is nothing but f of x, right? So we are defining two separate functions and we are proving them to be equal to our original function. Okay, now just see this. What is 1 minus x? 1 minus x is a polynomial function. It is everywhere continuous. What is mod of x? Mod of x is everywhere continuous for all real numbers. So the sum of these two will always be continuous. Therefore, g of x is the thing which is inside everywhere continuous. G of x is everywhere continuous. Okay, and therefore we can say that h of g of x is also continuous everywhere. And because h of g of x is continuous everywhere, f of x is also everywhere continuous. So what we are doing is we are breaking down this function into small parts and proving that it is everywhere continuous. Okay, so that is how you prove it. Now we have this huge exercise 5a, which has got around, let me tell you, many questions. 39 with sub questions, so it's a huge homework. Okay, so do it slowly. I'm keeping on making the videos on this particular part as we move ahead. Till now I have finished the chapter with many examples, different examples. Our understanding of solving the questions of continuity has improved a lot. Our concepts is clear. So only you have to face some more challenging questions now. And I know that you are going to face some doubts, but we'll try to get your doubts solved as soon as possible. Till then, I think you should watch this video very carefully and then try the exercise so that you get minimum amount of doubts. All right, so I'll be seeing you in the next video very soon. Till then, take care of yourself. Bye bye.